Buckle up, Earthlings. A fierce geomagnetic storm is currently unleashing its fury on our planet, and experts warn that it could intensify to severe levels. This isn't just some sci-fi plot, it's real, and it's happening right now. But here's where it gets controversial. While some dismiss geomagnetic storms as mere cosmic fireworks, others argue they could disrupt our modern tech-dependent world in ways we underestimate. Stick around as we dive into the latest NOAA update, breaking it down simply so even beginners can grasp the excitement and potential risks of space weather. First, let's clear up what we're dealing with. Geomagnetic storms occur when charged particles from the sun slam into Earth's magnetic field, much like waves crashing against a beach during a tempest. These disturbances can wreak havoc on our technology, from satellites to power grids. NOAA, the National Oceanic and Atmospheric Administration, rates these events on a scale from G1, minor, to G5, extreme, with G3 meaning strong and G4 escalating to severe. Think of it as Mother Nature turning up the dial on solar wind, potentially causing auroras, communication glitches, and even power outages in extreme cases. According to the latest space weather conditions report from NOAA, G3, strong, geomagnetic storming is ongoing, based on observations from the past couple of periods. And this is the part most people miss. A coronal mass ejection, CME, from November 11th is set to arrive later today, likely prolonging these heightened conditions into November 14th, UTC time. For those new to this, a CME is like a massive burst of solar plasma and magnetic fields hurling toward Earth. Imagine a cosmic tidal wave that could amplify the storm's effects. Now, let's look at the data. The 24-hour observed maximums and latest observed readings for radio, R, solar, S, and geomagnetic, G, events all show no data at this moment. That might sound alarming, but it simply means the monitoring systems haven't captured any specific peaks yet. Space weather can be unpredictable, and readings are updated in real time. For context, R1, R2 indicates minor to moderate radio blackouts, R3, R5 signals strong to extreme disruptions, while S1 or greater notes solar radiation storms that could affect satellites. Geomagnetic levels are similarly scaled, with current conditions reflecting the G3 storm. In terms of real-world impacts, HF, high-frequency, radio communication is experiencing weak to minor degradation on the sunlit side of Earth, with occasional losses of contact. Low-frequency navigation signals are also degraded for short intervals, which could affect things like GPS accuracy for ships or airplanes. These effects are like static on a radio dial or a brief hiccup in your phone's signal, minor for most, but critical for pilots, sailors, and emergency responders. For a deeper dive, check out NOAA's explanation of their space weather scales at https://www.swpc.noaa.gov/NOAA-scales-explanation. It's a fantastic resource to understand how these ratings translate into everyday risks. But here's where the debate heats up. Is this all just hype, or should we be investing more in protecting our infrastructure from space weather? Some experts argue that geomagnetic storms are rare and often overhyped, while others point to past events like the 1989 Quebec blackout as proof of their destructive potential. Could our reliance on technology make us more vulnerable than ever? What do you think? Should governments prioritize space weather preparedness, or are we overreacting? Share your thoughts in the comments below. I'm curious to hear if you agree that these storms demand more attention or if they're just another natural phenomenon we can weather through.